Hello and welcome to this video in the R Analytics course. In the previous video, we had seen different objects in R such as vectors, factors, matrices, etc. In this video, we will look at the data structure vector in depth. Vectors are the data object which can store data in one dimension, and the data has to be of the same type, either numeric or character. Suppose we write A is equal to 10. This is a single value vector. We define B is equal to Mumbai and then execute it to see the value stored in it. This is also a single value vector. The difference between vector A and vector B is that vector A has numeric type data and B has character type data stored in it. Thus, we can store both numeric and character type data in vector, but they have to be separate. One vector cannot store both. If we want to make a vector with multiple values, then we write A is equal to combination of 2, 4, 5, 7, 8 and 9. Now when we execute A, we can see all the elements of A in front of us. We can also create a sequential data set by writing A is equal to 5 to 15. In this case, all the numbers from 5 to 15 will be stored in A. We can see that by executing A over here. In case of storing multiple text values, we write B is equal to Delhi, Mumbai, Chennai, Noida, Gurgaon and so on. We must put them in quotes to ensure that they are read properly by R. Now how do we handle these vectors? Suppose we want to remove A from memory. For that we write RM, which stands for remove from memory, and then in brackets we put A. We can see on the top right corner that A is no longer there in the memory. We define another vector with name A and these elements in it. We want to now add 5 to all the elements of A. For that, we write A plus 5, and we can see that each element of A has been increased by 5 since it has been added to them. Remember, whenever we use an operator like plus, minus, multiplication or division for a scalar on a vector, then every element of the vector is impacted by it. For example, here every element was added by 5. If we would have multiplied the vector by 5, then every element would have been multiplied by 5. Now we want to find the mean of A. We write this, and we can see the output in the subsequent row. Suppose we open an Excel file and create a column of values under the header Sale. This is nothing but a vector. Basically, every column or row in a table with the same data type is a vector. Right now, the vectors are being shown as a row in R. To convert this into a column, we can make this into a data frame. For example, we write as.data.frame and then put the vector A in brackets. We can see the output we get is in a column form with a header. To convert A back to the vector form again, we write as.vector and put A in brackets. The as keyword basically converts the value into the data structure that is mentioned right after it. Like we saw here, that when we wrote as.vector, A got converted into a vector, and when we had mentioned as.dataframe, then A was displayed as a matrix. Another function we use is is.vector. This basically helps us check if a given variable is a vector or not. The is keyword is related to information functions. If we write is.vector a, here we get the result as true, which means that a is a vector. There are some functions in vectors. For example, we can write sum of a to find the sum of elements in a. Now we want to see that how many elements in a are greater than 4. For that, we can write a is greater than 4 and get this result. We see we get a value of true or false for every element in a depending on which element is greater than 4 and which one isn't. But we do not want to see which ones are true and which ones are false. We want the values itself of the elements which are greater than 4. For that, we have to learn to access the values of elements of a vector. To access the values, we use square brackets. We write a, and then in square brackets we write 4. This gives us an output of 5. The above statement we wrote basically tells R to let us know the value of the fourth element in A. We can check up here that the fourth element indeed is 5. Say we want the third element in B, so we write this and get the result as Chennai. By executing B, we can all see that the elements present there and the third element here is Chennai. Now what we had to do was to get the values of those elements in A which are greater than 4. One shortcut to see all the codes or functions we have used till now is to press the up arrow. As we keep pressing the up arrow, it will display the functions we have used till now. If we press the down arrow, then it goes the other way round. Coming back, we write a is greater than 4 and put it in the square brackets and put the name of the vector in the beginning. Now when we press enter, we get the output as 5 and 8 because these are the values of the two elements in A which are greater than 4. Similarly, we can use the less than operator to find the necessary values. Another function we use in R is very similar to the find function of Excel. What find function does is that it finds the position of a character in a word. Similar to this, we have a function called grepl. The first argument is what we want to look for in the word. Say we put it as E. The second argument is where we want to look in. Say we want to look for it in vector B. Now when we press enter, we get true for the elements where there is an E and false for wherever there isn't any E. We can see that there is an E in Delhi, so we got true for it. There is no E in Mumbai, so the answer was false. Now, if we put this in square brackets with the vector in the beginning, we get the values of those elements in which E is present, Delhi and Chennai. The next function we look at helps us to sort the elements in a vector. For that, we write order and then we write B. The output has been given to us in numbers. These numbers are arranged alphabetically. So Chennai would be the first element if we arrange all the elements of B from A to Z. This is why we have 3 in the first place, which basically tells us that the third element of B will become first if we arrange them alphabetically. Delhi, which is actually the first element, will come in the second spot. Gurgaon will come in the third spot, which is actually the fifth element. Then Mumbai and finally Noida. To simplify this and get the result in one go, we use the square brackets to arrange these elements alphabetically. We can see we get the desired result. There are other ways of sorting data as well, for which we need certain packages. We will look at them in later videos. Suppose we create a vector SB and put these elements in here. SB stands for Savings Bank Account. These elements indicate the number of accounts opened on each day of the week starting from Monday to Friday. Similarly, we make another vector CC for current account. Now we want the total number of accounts opened on each day irrespective of the type of account. For that, we have to just write SB plus CC. This will give us the total of each element, which is nothing but the number of accounts opened on a given day. Please remember that when we add, subtract, multiply or divide any two vectors, then we must ensure that the length of the vectors is the same to get an appropriate output. In case we have different lengths, then we have two scenarios that arise. First is where the longer vector has a length which is a multiple of the length of the shorter vector. For example, if one vector has two elements, then the other may have 4, 6, 8 or any other number which is a multiple of 2. If this is the case, then the operator we use will function. We had seen this in our previous video too. Second case is where the longer vector is not a multiple of the shorter one. In this scenario, an error would pop up and the operator would not function. Now what we want to do is give a header name to all the elements in SB. So we write names and put SB in brackets and put that equal to Monday, Tuesday, Wednesday, Thursday and Friday. We do the same thing for the CC vector. Now when we execute SB, we get this result. This shows us that 10 accounts were opened on Monday, 15 on Tuesday and so on. Basically, now all the elements are coming up with the names or headers assigned to each one of them. Now if we want to see the fourth element in SB, we get the output as 20 with Thursday on top. We can see the same thing for CC. Now when we add these two vectors, we get the same result but with the headers this time. If we write sum of SB and CC, then it will give us the total of all the elements in both the vectors. We can find the mean of both SB and CC by using the function mean. These will tell us that how many accounts were opened on an average of each type. We make another vector by the name days. Now we can use this vector also to give the headers to SB or CC vector. For that we write names SB equal to days. There is another way to create a vector. For that we write D is equal to sequence, from equal to 1, to equal to 10 and by equal to 0.5. Now when we execute D, we get all these elements from 1 to 10 which are increasing by 0.5. We can give any such sequence and tell R the step size we want to ensure so that we get the desired outcome. We can see that vector E has all the values from 100 to 500 which are increasing at steps of 50. This is how we create vectors and handle them through various functions. This is it for this video. Thank you.